Welcome to another lecture on gate class. So today we will discuss the properties of region of convergence. That is also we are writing in short form, that is ROC. So let us discuss the first property. So first property is the ROC, the region of convergence does not contain any pole, So basically let us take an example. Xt is equals to e raised to the power minus at into ut. So the Laplace transform of this signal is 1 divided by s plus a. And what is the ROC? So ROC is real part of s greater than minus a. So this is our ROC. So why the ROC is not containing any pole? So if we see that expression, expression of xs, then at s is equals to minus a, xs will tends to infinity. So basically we are avoiding the pole, because at poles the transfer that Laplace transform, the system will become unstable, and that xs will tends to infinity, means xs is not defined when we have s is equal to minus a. So we are avoiding the pole. So that's why, because the region of convergence is basically the region in which the series will converge, in which the Laplace transform is possible. So in this region we are avoiding the poles. Okay, so this region, if suppose a is greater than 0, if a is greater than 0, then this is the region of convergence. So this region of convergence is not containing the pole. This region of convergence is not containing the pole. Second property is if xt is a finite duration signal, that is xt is equals to 0 except in a finite interval t1 is less than or equal to t is less than t2, minus infinite is less than t1, and t2 is less than infinity. So between t1 and t2 it has some value, some finite value, and except this the value is 0, except this xt is equals to 0. So this is xt is equals to 0. Then the region of convergence, then the ROC is the entire S plane, then the ROC is the entire S plane except possibly s is equal to 0 or s is equal to infinity. So let us take an example, that xt is del t. So xt is del t. If we are taking xt is equal to del t, So basically it is a finite signal. Only at t is equals to 0 it is tends to infinity. So this del t is a finite signal, finite duration signal. Del t is finite duration signal. So that Laplace transform is 1, and the ROC is basically the entire S plane. We can see that ROC is entire S plane. Let us take another example. Let us take xt is equals to ut. Then the Laplace transform is xs, and that we already know that Laplace transform is 1 by s, and the real part is of s is greater than 0. But if we see the Laplace transform of this signal, then at s is equals to 0, the xs will be infinity. So xs becomes infinity at s is equal to 0. So the ROC is basically ROC is real part of s greater than 0. The ROC is real part of s greater than 0. So basically it is not defined at s equals to 0. The ROC is not possible at s equals to 0. Now let us take another property. Okay, let us take an example related to finite duration signal. So another finite duration signal. Let us take another finite duration signal. So the signal is xt is equals to del t plus del t minus 1. Then what should we then what will be the Laplace transform? We can find out the Laplace transform. So the Laplace transform of this signal is xs is equals to minus infinity to plus infinity del t plus del t minus 1 e raised to the power minus st into dt, and that is equals to minus infinity to plus infinity del t e raised to the power minus st into dt plus minus infinity to plus infinity del t minus 1 e raised to the power minus st into dt, and that is equals to 1 plus here we can apply the property again. So it is del t minus 1 e raised to the power minus s into 1 into dt. So it is 1 plus e raised to the power minus s into 1. We have just applied the property here. So it is 1 plus e raised to the power minus s. So the Laplace transform of this signal is 1 plus e raised to the power minus s, and the ROC we can see that the ROC is again, and it is the entire s plane. The ROC is entire s plane. So this is our ROC. So ROC is entire S plane. The ROC is again entire S plane, because there is no problem in convergence of this series. The series will converge. So it is entire S plane. Also, if we put S equals to 0, then we will get e raised to the power minus 0 is equals to 1, so finite value. And we have s, when we have s equals to minus a plus infinity, then it is 0. But when we have s equals to minus infinity, it will not converge. It will so we are avoiding s equals to minus infinity value. So next property is if xt is right-sided signal, if xt is right-sided signal, that is xt is equals to 0 for t less than t1 less than infinite, then the ROC is of the form real part of S is greater than sigma max. So what is sigma max? So where sigma max equals the maximum real part, the maximum real part of any of the poles of excess. Thus the ROC is a half plane to the right of the vertical line, to the right of the vertical line, and real part of S is equals to sigma. The real part of S is equals to sigma maximum in the S plane, and thus to the right of all the poles of excess. So in short, if the signal is right sided signal, then the ROC is basically right of the rightmost pole. Please understand, again I am saying again, if the xt is a right sided sequence, if xt is a right sided sequence signal, then the ROC is right to the rightmost pole. So let us take an example for this. We have xt is equals to e raised to the power minus 2t into ut plus e raised to the power minus 3t into ut. So the Laplace transform of this signal is xs, that is equals to 1 divided by s plus 2 plus 1 divided by s plus 3. Then the ROC, because both signals are right sided signals, then we can find out that here the ROC. So the first we are going to write the complete signal. So it is s plus 2 plus s plus 3 divided by s plus 2 multiplied by s plus 3. So basically the poles are s is equals to minus 2 and s equals to minus 3 are poles. So these are poles. Now what is ROC for this Laplace transform? So we have xs is equal to x1s plus x2s, and x1s is 1 divided by s plus 2, and the ROC, since it is a causal signal, the ROC is real part of s greater than minus 2. Then we have x2s, that is 1 divided by s plus 3, and the ROC is real part of s greater than minus 3. Now if we see the region of convergence, then we can find out that this is our minus 2, this is our minus 3, then real part of s is greater than minus 2. So real part of s is greater than minus 2. This is first ROC, and second ROC is real part of s is greater than minus 3. This is second ROC, Now we can easily see that the common ROC, the common overlapping region is -2. So the ROC is basically -2, real part of S greater than -2. So this is the ROC, this is the region of convergence. So the ROC of XS is real part of S greater than -2. Now the important conclusion is this is a right-sided sequence. That is clear that it is a right-sided sequence. Then the poles are, so sigma 1 is -2 and sigma 2 is -3. So the sigma maximum is -2. If we compare -2 with -3, then see -2 is greater than -3, so sigma maximum is -2. So and ROC is of XX is nothing but real part of S is greater than -2, and this we can also say that it is sigma maximum of the value -2. So so this proves our property that the ROC of right-sided sequence is right-sided signal is outer to the outermost pole. So the outermost pole, the right to the rightmost pole. So the rightmost pole is sigma equals to is at S equals to -2. So this is our rightmost pole, and so the ROC is nothing but real part of S greater than sigma max, that is real part of S is greater than -2. So we have -2 and -3. So this pole is rightmost pole. So we have ROC is right to the rightmost pole. ROC is right to the rightmost pole. So this property, hence we have proved this property. Now next property is, so we have considered the right-sided signal. Now in this case we can consider the left-sided signal. So if xt is left-sided signal, that is xt is equals to 0 for t1, for t is greater than t2 is greater than -infinity, then the ROC is of the form, real part of S is less than sigma minimum, So what is sigma minimum? Where sigma minimum equals the minimum, real part of any of the poles of XS, Thus the ROC is a half plane of the left of the vertical line vertical line real part of S is equals to sigma minimum. So that the line which belongs to real part of S, the vertical line which belongs to real part of S is equal to sigma minimum in the S plane, and thus to the left of all the poles of axis. So this let us take an example. The example is xt is equals to minus e raised to the power minus 3t into u of minus t minus e raised to the power minus 2t u of minus t. So let us find out the Laplace transform. So xs is the Laplace transform of minus e raised to the power minus 3t into u minus t plus Laplace transform of minus e raised to the power minus 2t u of minus t. Then what is the Laplace transform? That it is xs is equal to x1s plus this is x2s. So x1s is 1 divided by s plus 3, and the ROC is real part of s is less than minus 3. We can check it. If we just remember the relation, then what is the Laplace transform of minus e raised to the power minus 80 into u minus t, then the Laplace transform is 1 divided by s plus a. If you remember the relation, minus e raised to the power 80 u minus t, then it is 1 divided by s plus a, and it is real part of s less than minus a. This is the ROC, real part of s less than minus a. If we remember the previous question that we have solved in the last lecture. So again we have x2s. So x2s is nothing but 1 divided by s plus 2, and please check these relations. We have solved this type of question in previous lecture, and this real part of s is less than minus 2. So we have again we can see that this is minus 2 and this is minus 3. Then the real part of s is less than minus 3 in first case. So if see that if we can see that so we can see that this x1s is 1 divided by s plus 3. The real part of s is less than minus 3. So we have less than minus 3 means more negative than 3, and then we have real part of s less than minus 2. It means more negative than minus 2. So we can find out that this is the overlapping region. So the ROC is real part of s less than minus 3. So the ROC of xs is real part of s is less than minus 3. Now let sigma 1 is equals to minus 3 and sigma 2 is equals to minus 2. So what is sigma minimum? So if we see that, then sigma minimum is minus 3. So hence we have proved the property that real part of s is less than sigma minimum. So because sigma minimum is minus 3, hence we have proved the property. So ROC is left to the leftmost pole. The ROC is left to the leftmost pole. The ROC is left to the leftmost pole. Now let us see again, let us see the next property. Let us see the next property. So the property is if, so we have seen the right sided signal, and also we have seen the left sided. Now we can see the both, means we can see the two sided signal. We can see the two sided signal. So if we will see the two sided signal. So if xt is two-sided sequence, if st is two-sided signal, then that is xt is an infinite duration signal. Xt is an infinite duration signal that is neither right-sided nor left-sided. Then the ROC is of the form sigma 1 is less than real part of S is less than sigma 2. So where sigma 1 and sigma 2 are the real parts of two poles, of axis, thus the ROC is a vertical strip. In the S plane between the vertical lines, real part of S is equal to sigma 1 and real part of S is equal to sigma 2. So let us understand this property by using an example. So xt is equals to e raised to the power minus 3t into ut plus e raised to the power 2t into u of minus t. So if we see that signal, this is the right-sided signal, and this is left-sided signal. Please check, this is left-sided signal. So xs is equals to x1s plus x2s, and what is x1s? X1s is 1 divided by s plus 3, and the ROC is, what is the ROC? ROC is real part of s is greater than minus 3. Then second thing is x2s, it is Laplace transform of x2t, so minus infinity to plus infinity, we can find out the Laplace transform of this signal e raised to the power 2t u of minus t e raised to the power minus st into dt. Now from minus infinity to 0, u minus t is equals to 1, and from 0 to infinity, this is 0. So we have minus infinity to 0 e raised to the power 2 minus s into t dt. So if we see that the series will converge, it will be it is integrable only when we have 2 minus s, that is real part of 2 minus s. So it should be positive. It should be positive. So real part of 2 minus s is greater than 0, then real part of s, then we can see that here we have real part of 2 should be greater than real part of s. So basically real part of s is less than 2. So this is the ROC. So this is x2s. Okay, we have to solve it. What is that final value? We have to see what is the final value, x2s. So here we can solve it. So the solution of this integral, is, we can say that it is simply e raised to the power 2 minus s divided by 0 minus 1 and minus infinity to 0. So if we further solve this integral, then we can find out that when we put t equals to 0, it is equals to 1, and okay, this is 2 minus s, sorry. So when t equals to 0, this value is equals to 1, so we have minus 1 divided by s minus 2. So this is our solution. So minus 1 divided by s minus 2. So xs is equals to x1s plus x2s. So x1s is 1 divided by s plus 3, and x2s is minus 1 divided by s minus 2. So we can see that the xs is equal to 1 divided by s plus 3 plus minus 1 divided by s minus 2. The ROC for this is a right-sided sequence, so real part of s is greater than minus 2. This is left-sided signal. The ROC is real part of s is less than 2. That we have seen. Now if we plot the signal, if we plot the ROC, then this is real, this is sigma, and this is j omega, this is s plane. So first is minus 3 is here, so it is greater than minus 3, then second less than 2, so this 2 is here, this 2 is here. So the ROC, we can see that the ROC is this region, it is the two vertical lines, the ROC is between two vertical lines. So this is minus 3 and this is 2, then the ROC is between these two vertical lines. So the ROC is between minus 3 is less than real part of s is less than 2. And please understand the ROC will not include any pole, so that's why I have not taken 3 is less than or equal to, I have taken only less. So ROC does not contain any poles. Here we have that prove that the ROC does. So this is a pole, this is also pole, this is j omega, here is sigma. So we can say that the ROC is not containing any pole. So let us do some problems related to this. So problem 1 is xt is given and it is equals to e raised to the power 2t u of t plus e raised to the power minus 3t u of minus t. Now we need to find out the Laplace transform. Find out Laplace transform of xt and also ROC. So the solution is xs is basically minus infinity to plus infinity xt e raised to the power minus st into dt. So it is equals to minus infinity to plus infinity e raised to the power 2t ut e raised to the power minus st dt plus minus infinity to plus infinity e raised to the power minus 3t u minus t e raised to the power minus st into dt. So we can see that this integral, let this is x1s and this is x2s. So xs is equal to x1s plus x2s. So what is x1s? So let us solve this first. So it is minus infinity to plus infinity e raised to the power 2t into ut e raised to the power minus st into dt. So it is nothing but 0 to infinity, because from minus infinity to 0 this ut is equal to 0. So we can change that interval from 0 to infinity only, and it is equals to e raised to the power 2t into 1 into e raised to the power minus st into dt. Then it is equals to 0 to infinity e raised to the power 2 minus s into t into dt. So here we can see that limit s tends to infinity e raised to the power 2 minus s will be 0 only when real part of real part of 2 minus s will be less than 0. In that case this integral will converge. In that case the integral will converge. So what is x1s is basically it is 0 to infinity e raised to the power 2 minus s into t. It is 2 minus s divided by so we can see that it is 2 minus s divided by 2 minus s, so it is 0 to infinity. So it is equals to 1 divided by s minus 2. We can check, you can check this solution. So what is x1s? So x1s is nothing but 1 divided by s minus 2, and the ROC is nothing but real part of s greater than 2. Now second part is x2s, that is minus infinity to, so this is our first part, that is x1s. So we have calculated the x1s. Now x2s is e raised to the power minus 3t into u of minus t e raised to the power minus st into dt. So it is minus infinity to 0 e raised to the power minus 3t into 1 into e raised to the power minus 3t into dt. So it is minus infinity to 0 minus s plus 3 into t into dt. So it will converge only when we have real part of s. It will converge only when we have real part of s plus 3 is less than is greater than less than 0. So real part of s is less than minus 3. So this is the reason of convergence. This is the reason of convergence, and the solution is 1 divided minus 1 divided by s plus 3. The solution of this integral is minus 1 divided by s plus 3. So we have x1s, it is 1 divided by s minus 2, and the ROC is real part of s greater than 2. Then we have x2s, that is minus 1 divided by s plus 3, and the real part of s is less than minus 3. So let us draw this. So we have first is 1 divided by s minus 2, so this is our second point, and then we have minus 3. So the real part of s is less than minus 3. A real part of s is less than minus 3 is this, less than minus 3 means this is less than minus 3. Then we have real part of s is greater than 2. So this is our real part of s greater than 2. So let us draw it again, because so this is our sigma, this is our j omega, then this is minus 3 and this is 2. So in this case real part of s is less than minus 3 when it is e raised to the power minus 3t into u minus t, and when we have e raised to the power 2t into ut, that is the Laplace transform is 1 divided by s minus 2, and real part of s is greater than 2. So the real part of s is greater than 2 and the real part of s is less than minus 3. Now we can see that x1x exists and x2x also exists, and the ROC for both these signals are exist. But the problem is that if we find out the common ROC, then we can say that there is no overlap. So no ROC is possible. No ROC is possible for XS. So since there is no common ROC, since there is no common ROC, so Laplace transform of xt is equals to e raised to the power 2t into ut plus e raised to the power minus 3t into ut is not possible. So the Laplace transform of this signal is not possible. Let us solve another problem. Xt is given as that is equals to e raised to the power minus a modulus t. So the question is find xs and sketch, find xx and sketch the zero plot, and sketch the pole zero plot, and the ROC for a greater than 0 and a less than 0. So the solution is that basically xt can be written as e raised to the power minus at into ut plus e raised to the power at into u minus t. So how to get this relation? How to get this relation? So basically we have xt is equals to e raised to the power minus a modulus t. This is our xt. Now what is happening that for t greater than 0, it can be written as e raised to the power minus at, and for t less than 0 it is written as xt is equals to at minus plus at. Now if we summarize this, we can for t greater than 0 it is e raised to the power minus at. So we can write we can multiply it with ut, because ut is only for a positive value of t, and here we are multiplying with u minus t because it is for negative value of t. So xt is written as e raised to the power minus at into ut plus e raised to the power at u of minus t. Now we can find out the Laplace transform for this signal. So we can consider both cases. For a greater than 0, when we have a greater than 0, so let us plot the signal. So let us plot the xt. So when a greater than 0, so this is basically this is decaying exponential, and this is also decaying. This is decaying exponential in positive side, and this is decaying exponential in left hand side. So the graph should be like this. So this is xt graph. At t equals to 0, the value is at t equals to 0, the value is 1 plus 1 is equals to 2. Now and at t equals to infinity it is 0, at t equals to minus infinity it is 0. So the graph is for a less than 0, the graph is like this. So this is graph of xt when a less than 0, and this is graph of xt. This is graph of xt when a is greater than 0. So let us find out the Laplace transform. So xt is x1t plus x2t, we can write it as, now x1t is e raised to the power minus at into ut, then x1s is 1 divided by s plus a, and the ROC is real part of s is greater than minus a. This is the ROC, real part of s is greater than minus a, and so sorry for that, there is some problem. So it is if we consider a greater than 0, then what should be that graph? What should be the ROC? So a greater than 0 means some positive value of a we are considering. So if we are considering some positive value of a, suppose we are considering 2, then minus 2 is here. So this is minus a for general. In general we can say this is minus a. So that real part of s is greater than minus a means this is the ROC. This is the ROC when a is greater than 0. This is sigma. This is j omega. This is s plane. And when we have a less than 0, then this is minus a, and this real part of s is greater than minus a. So this is the ROC when we have a less than 0. So this is the ROC when we have A less than 0. So we can consider both cases. Now let us plot x to t. So x2 let us plot x to x. So x to t is e raised to the power at into u minus t, and the Laplace transform x to s is minus infinity to plus infinity x to t e raised to the power minus st into dt, and that is equals to minus infinity to 0 e raised to the power at e raised to the power minus st into dt, that is minus infinity to 0 e raised to the power a minus s into t into dt. So the solution is minus 1 divided by s minus a, and ROC is real part of s less than a. ROC is real part of s less than a. Please check this. So again, that x2s, we can plot the ROC for x2s, that is minus 1 divided by s minus a, and the ROC we are getting is real part of s less than a. Now we can plot this. So we have this this is sigma, this is j omega. Now if we consider a less than 0, a greater than 0, it means somewhere we have a here. So real part of s less than a means this is the ROC when a is greater than 0, and when a is less than 0, this is sigma, this is j omega, and when a is less than 0 means somewhere here we have a less than 0, then it is real part of s less than a. Now you can see that again the ROC is not containing any pole. So we have considered both the cases when we have a greater than 0 and when we have a less than 0. Now let us see that what is happening when we are taking combined signal. So xs is equals to x1s plus x2s. So the first case, first is that we are getting x1s. So x1s we are getting is 1 divided by s plus a, and x2x we got is 1 divided by s minus a, and the ROC for this is real part of s is greater than minus a, and here ROC is real part of s is less than a. Now let us take both cases. So for a, now take a greater than 0 and find out the ROC of xs, that is common ROC. Our task is to find out the common ROC. So first when we considering a greater than 0, then a greater than 0 means here we have minus a, and it is real part of s greater than minus a means this is the ROC for this part x1s. Now we have considered a greater than 0 means a greater than 0, so we have real part of a less than 1. So for that second signal less than a, real part of s is less than a. So the ROC is basically the ROC when we are when we have real part of s. So first in case 1, please understand that in case 1 we have considered that a greater than 0. Now a greater than 0 means take any value. Let us take is 2. So in that x1s, the ROC is real part of s is greater than minus 2. So the greater than minus 2 is here. Then minus 2 should be here. Okay, let us plot it again. This is 2 basically. This is 2 minus of minus is basically 2, so it is greater than basically minus 2. Then greater than 2, so because we have taken positive value of so it is 2 only, so again we are getting the same. So here overlapping is taking place, so here overlapping is there, so overlapping is there. So I am again explaining this case. So a greater than 2 0 means take a is equals to 2. So for this part we have real part of s is greater than minus 2, and for this part we have real part of s is greater than 2. So let us plot that. Let us plot the ROC. So minus 2 is here and 2 is here. So greater than minus 2, then we have greater than 2. So that I have shown in your previous slide that the ROC is basically we have this common ROC because overlapping is there. So common ROC is real part of s is greater than 2. So the common ROC is real part of s greater than 2. So again I am summarizing. So xx is equal to x1s plus x2s. So xs is equals to 1 divided by s plus a minus 1 divided by s minus a, and the ROC is nothing but real part of s greater than real part of s 1 minute we have so what we have seen that xs is equals to x1s plus x2s, that is equals to 1 divided by s plus a plus 1 divided by minus 1 divided by s minus a. And here the ROC is real part of s greater than minus a. Here ROC is real part of s less than a. Now if we consider for a greater than 0, if we consider a greater than 0, so let us plot the common ROC. Now take any value which is greater than a. So let us take a is equals to 2. So it will become real part of s greater than, it will become real part of s greater than minus 2, somewhere here. And then we have so this is 2, suppose this is 2, a is equals to 2, then it is greater than minus 2, second is less than 2, so 2 is here we have 2, so greater than minus 2 is more positive, means minus 1 is greater than minus 2, so all these values are greater than minus 2, so this is our ROC for that x1s. And for second case the ROC is for this is x2s, the ROC of x2s. So what is the common ROC? So the common ROC is between, so the ROC of xs is minus 2 is less than real part of s is less than 2. So this is the ROC for xs. This is the ROC for xs. Now if we take the if we take a less than 0, for a less than 0, then what is happening that let us take any value. So let us take a is equals to minus 1. So real part of s greater than minus a means it is greater than 1. So 1 is here, then greater than 1 means it is greater than 1 means this is greater than 1. So this is real part of s is greater than 1, and second is real part of s less than minus 1. So minus 1 is here, so less than minus 1 is here. Now we can see that there is no common ROC. We can see that there is no common ROC. So for a less than 0, the Laplace transform is not possible. So let us summarize the what we have seen in this question. So xs is nothing but 1 divided by s plus a plus minus 1 divided by minus 1 divided by s minus a, and for a less than 0, no overlap is there. So no common ROC is possible. So Laplace transform does not exist when a is less than 0, and for a greater than 0, common ROC, common region of convergence, exists. So Laplace transform is possible. Laplace transform is possible. Let us do another problem. Xt is given as e raised to the power minus at, and it is between 0 to t only, capital T only, and it is equals to 0 otherwise for all other values of small t. Then find the Laplace transform of xt. So let us solve this problem. So the Laplace transform is xs, that is minus infinity to plus infinity, xt e raised to the power minus st into dt. So it is xs is equals to minus infinity to 0 xt e raised to the power minus st into dt plus 0 to capital T xt e raised to the power minus st into dt plus capital T to infinity xt e raised to the power minus st into dt. So why I have written in 3 form? Because xt is only exists between 0 to t. So this value and this value is 0. So finally what we will get, xs is equal to 0 to t, it is minus e raised to the power minus at into e raised to the power minus st into dt. So finally that solution is 1 divided by s plus a, 1 minus e raised to the power minus s plus a into t. Now so that xs is the xs is 1 divided by s plus a, 1 minus e raised to the power minus s plus a into t. So this is our Laplace transform. Now if we see that we see the Laplace transform, so basically xt is a finite duration signal. Since xt is a finite duration signal, the ROC of the ROC of XS is the entire S plane, is the entire S plane. It appears that XS does not converge at S is equals to minus A, but in this case, x minus a is nothing but 0 to capital A e raised to the power minus at e raised to the power, just put s equals to minus a in that expression dt, the calculation is t. And if we apply the limit also, if we see that if we apply the limit at s tends to minus a, 1 divided by s plus a, 1 minus e raised to the power minus s plus a into t. Then if we apply the L'Hospital rule, then what we will get? 0 minus e raised to the power minus s plus a into t into minus 0 plus 1 into t divided by 1 plus 0. So the L'Hospital rule again giving the same result. So it appears that this is undefined due to this term. If we see the expression, it appears that because if we put s equals to minus a here, it will turns to undefined. But when we are putting the limit, when we are using the L'Hospital rule, we find that it gives the finite value, that is capital T. So the ROC, so the conclusion is that ROC is basically the entire S plane. The ROC is entire S plane. So all the values of for all the values of S, this Laplace transform will exist.